Our fifth presenter is Raouf Belkhir from Dietrich College. Raouf's title is When No Error Isn't the End of the Story.
For most of us, saying the right word at the right time seems effortless, until you're told that you need brain surgery, and suddenly, that ability is at risk. During brain surgery, surgeons remove harmful tissue, while trying not to damage the parts of the brain that make us who we are. That's where awake brain mapping comes in. Patients are woken up in the middle of surgery and asked to name pictures, like apple, chair, dog, while the surgeon gently stimulates different parts of their brain. If stimulation causes an error, that tissue is protected. If it doesn't, it may be removed. This is the clinical gold standard, and that single judgment can determine whether a patient wakes up able to speak. For over 50 years, awake brain mapping has relied on one simple rule: no error means no function. But here's the problem. More than 90% of stimulation trials produce no obvious error, so large parts of the brain end up labeled as safe. Yet some patients still wake up with language problems. So my research asks the critical question: when stimulation causes no error, does that brain region really not matter, or are we just not measuring the right thing? To answer this, we studied thousands of trials from awake neurosurgery. And instead of treating errors as the only signal, we measured how long it takes patients to speak. We found that sometimes stimulation has no effect, and other times it slowed speech, even when responses were correct. It's like traffic on a highway. If one or two lanes are down, the highway doesn't always close. Everything just moves a bit slower. And that's because speaking isn't just one step. It's a sequence. You recognize the object, find the word, plan the sounds, and then move your mouth. Depending on where and when we stimulate the brain, different steps in that sequence slow down. Early stimulation slows finding the right word. Later stimulation delays actually saying the word. And the size of that delay tells us something deeper: how essential a region is at that moment, or how easily the rest of the brain can compensate. We call this causal parametric mapping, treating brain stimulation as a graded signal, not just a yes or no test. In other words, no error doesn't always mean no function. Sometimes, the most important signals aren't the ones that stop behavior, they're the ones that slow it down. And in brain surgery, that can be the difference between losing the ability to speak and preserving someone's voice. Thank you.